This time, we are going to convert decimal to hexadecimal number. We are going to divide the decimal number by 16 until the quotient becomes 0. And we're going to read it backwards because the rule states that we're going to write it in a reverse manner. So meaning we're going to base it from the most significant bit going to the least significant bit. Okay. In our module, we have a decimal number which is 1128, and we are going to divide it with 16, the radix of the hexadecimal number. We're going to divide first the first 3 digit, 112. So 112 divided by 16, we have 7. 7 will be multiplied to 16. We have 112 and a difference of 0. We bring down 8. So we are going to divide 8 with 16. So we have 0 because this can't be. And then 0. And we have our least significant bit, which is 8, our remainder. So after that, we will proceed to the second division. We are going to divide the quotient, which is 70, with 16. We have 4. 16 multiplied to 4, we're going to have a product which is 64. And we have a difference of 6. Okay? Next, we are going to divide 4 with our radix 16. So 0, 0, and we have 4. 4 is the most significant bit. So therefore, in our answer, we are going to start with 4 instead of 8 because 8 is the least significant bit. The answer is 4, 6, 8. This is the hexadecimal form of a decimal number 1128. Okay? So 1128 is equivalent to 468, a hexadecimal. Example in our module is a decimal number which is 188. So this is a decimal number. So we put base 10 because that is a hexadecimal number. We are going to convert it into a hexadecimal number. So again, the process is we are going to divide 188 with 16. Okay? So we have 1 and then a product which is 16 and a difference of 2. Okay? We bring down 8 to make it 28. So now we are going to divide 28 with 16. So still we have 1 and then we have 16. So the difference is 12, or we will write C. Okay? Please refer to your hexadecimal table. The hexadecimal equivalent of a decimal number 12 is C. Okay? Our least significant bit is C, which is our first remainder. Okay, we proceed now by dividing 11 with 16. So we have 0 and then 0 and a difference of 11, or we will write B. Okay? So please refer on your table for hexadecimal number. 10 is equivalent to A, 11 is equivalent to B, 12 is equivalent to C, 13 is D, 14 is E, and 15 is F. Okay? So the hexadecimal equivalent of a decimal number 188 is equals to B, C. Okay? This is hexadecimal, this is decimal. Okay, our next example in your module is another decimal number to be converted into a hexadecimal number. The decimal number is 256. We are going to divide 256 again with 16. Okay? So we have 1 and then 16, and we have a difference which is 9. We have to bring down 6 to make it 96. Okay? This time we're going to divide 96 with 16. So we have 6. 16 will be multiplied to 6. We have exactly 96. And we have our first remainder. Our least significant bit is 0. Okay, so this time we're going to divide 16 with 16. 16 will be divided by 16. So we have 1, 16, and we have a remainder 0. So this time we will divide 1 with 16. So 1 will be divided by 16, so it's gonna be, so we put 0 and then 0, and we have the remainder which is 1. 1 is our most significant bit. Again, so we are going to read it in a reverse manner. Okay? So first 1, 0, 0. Okay? 256, which is a decimal number, is equivalent to 100, which is a hexadecimal number. That is how you convert a decimal number into a hexadecimal number. You divide the given with 16. Do not stop dividing until the quotient becomes 0.